let's start working on this old chassis here by getting the power transformer out. You can see the solder connection here is very poor anyway, and you guys have already seen how the electrolytics were tacked in at some point. We'll clean that up a bit. The one thing too I wanted to point out for folks that are new to the hobby, you may look at this tube here from the bottom side and try to understand where the pins are. Again, this is a Type 80 rectifier. You know, get yourself a tube manual. They're available for download if you hadn't already done so. But if you're looking from the tube underneath like we are, and if I were to rotate this around in this direction, I'll see if I can hold it here, where you've got your two big fat pins here at the bottom and your two smaller pins at the top. If you go to your left, that's always pin 1. So you pin 1, 2, let me get a pointer here. Pins 1, 2, 3, and 4. So you can see how simple that is. And again, if we go to the schematic itself, which I did find, and by the way, this particular Peter Pan radio was manufactured by the Gilfillan brothers out in Los Angeles, and it's a Type 4T. So you can see they're showing 1934 to 1935. I think I said it was a 1933, and I got that by another radio that was on display that was labeled as a 1933. So early to mid 30s. Anyway, you can see the Type 80 tube here, and you can see the connection points. Again, those big thick lines that we were seeing here, leads coming from the power transformer, are your filament voltage to the Type 80 tube, and your high voltage windings again would be P3 and P2 that you see I have labeled. We'll do the DC resistance measurements here and document that for others doing the restore, and I'll do the same here for the filaments as well. So I've got the soldering iron heating up here. Let's go ahead and see if we can't clean these solder joints out and off the tube sockets here, and go ahead and free ourselves of the power transformer this morning. Alright, let's go ahead and clip the power cord out here. Okay, what I'm doing here is just sizing up the length of the leads here coming from the power transformer, and you can see I've got a little extra to work with. So what I'm going to do is just cut these off right at the tube socket itself on the solder lugs, and it looks like the high voltage winding here, that I'm okay there, and I'm okay here as well. So I think I'll do that, and then that affords me to get down in there and clean those up a bit better, and not take a chance of maybe breaking one of the tabs off the socket, which I've done before. You see there, I'm going to just get as close as I can. There's a better look now at the Type 80 tube socket. Again, what I was referencing here, pin number 1, 2, 3, and 4. Again, your filaments and your plates here. Alright, got the soldering iron cleaned up here. Let's tin it real quick. What I'm going to do is just see if I can pull this wire loose after I apply some heat, because I think it's just laid on here. Yeah, you can see how it was connected there. Not much of a solder connection. Let me get my solder sucker here. So again, not the type work that you want to do. Okay, I'll tell you what I'm going to do just for now. I've got this cleaned up. I probably can reuse this. I'll clean it up a little bit more here with some alcohol in just a bit. Let me see if I can get just a little bit more of the solder off, but I'm going to probably go ahead and leave this B plus line that runs over probably to the RF coil. Alright, you can see we'll just repeat this process here, going around to each of the 4 pins and getting these tabs cleaned up. Okay, you can see I got my alcohol bottle here. Let me just go ahead and dab a little alcohol on here. The solder joints have cooled down, and I'm going to just take a Q-tip here for right now because I want to get right around the base of the tube. And then I'll get one of my brushes here and we'll clean up the tabs themselves. So this will get rid of some of the crud and flux here that resides on the socket itself. Okay, again with the alcohol back out, I'm going to just take one of my acid brushes here and do the same thing. And just go back around these tabs themselves to clean those up, and we'll have a nice solder connection point there once we reattach the leads from the power transformers and the others. Alright, just a little force there just to kind of clean up. So that looks like a dinner plate you'd want to eat from now. Alright, one thing that's interesting about this particular transformer, you can see again, you've got your high voltage winding here with your center tap, and we'll measure those voltages as well as the DC resistance for future restores. So they've got that reference point, but again, we should read 5 volts here, feeding the type 80 to the filaments. But if you look at these tubes up here, the 58 tube, which is your RF amplifier, and I think the 57 is going to be your detector, and this is the 2A5 is going to be your output tube. All these tubes were introduced, I think, late 1931 to early 1932, and the heaters, which are indicated here with a small X, and same thing here, are 2.5 volt. So when we measure the voltage off of this secondary side here for this tap location, it should be roughly 2.5 volts. And you can see there is a center tap that shows it going to ground. So let's identify those tie-in points now, and go ahead and get the remaining 3 leads loose, unless the third one itself is tied here to the bell housing itself. The other lead off the transformer too will be that center tap location. Right here. So I failed to call it out, and you can see if you follow it around, it comes up, and I've already notated the polarity of the electrolytic caps here. C7 and C8, looks like a 4 almost, but C7, C8. Again, we've got 10s plugged in the radio. It looks like the schematic call for 4s. I think 10s will probably be fine. One thing that's interesting, you'll see this on the schematic. It really could be confusing. Again, I drew in the plus minus polarity, but you can see here, if you're just looking at this schematic, it may appear that C7, the positive lead, goes to the chassis ground indicated here. But I think what they're referencing here, if you read voltage between the chassis ground and the center tap of the transformer, again you'll see that the center tap is most negative and the ground itself is more positive in nature. So the center tap location is always the most negative point. Anyway, again, if we follow this center tap lead over, you can see where it should make a connection with capacitor C8. Let's see if that's the case, as well as connect itself to the field coil, which is indicated here with 2500 ohms. Okay, here's what I believe to be the center tap location here, and you can see it's coming across and it's just going to this terminal strip here. And it's not attached to ground here, and you can see the negative lead here goes back to this particular capacitor, which is correct looking at the schematic. And the other capacitor that we looked at, again you can see here negative, ties back to the chassis ground here. So this is tied in correctly. Now if we go back in here and look at the other wires that are tied to this point, there's one down here that goes nowhere. It's just cut off that we'll have to clean up. And there looks like there's the second wire here, and this is probably not going to show up well, but it's right here, this wire, and you can see it running down through this grommet, which heads back over to the speaker assembly, and that should be going again back over to the field coil itself. Alright, again this is a kind of a nasty solder joint here, so let me just apply a little heat here and see if I can actually just pull this loose. Yep, there it came. That's what I was talking about. Some of this stuff was not really tacked in the correct way. So again, this will be the center tap location here. Goes back to this point, and again this other lead right here should be going to the field coil, and we'll verify that in just a bit, just to make sure that we read close to the 2500 ohms. Okay, the other connection point here for the ground itself for this particular heater, for the 2.5 volt string, or the transformer itself, I'm assuming is right here. You can see the big thick lead that comes out, and looks like we've got a really nice solder joint here back to the chassis ground. Okay, you can see the other lead coming from the base of the transformer here, and it attaches itself here to this tube, which is the type 58, and this should be your RF tube for this particular TRF receiver. And we'll go back to that tube socket in just a minute, but you can always tell again the filament or heater wires from the transformer. Of course there's more current flow, so thus you need a larger gauge, unlike the high voltage here, again when you're operating at milliamps. Anyway, going back to this tube base, if it's showing up on camera, I've got this positioned again. This is 6 pins versus 4. But again, you see you got your 2 fat pins here, so the one furthest left is pin number 1 here. So again, if you go in a clockwise position, 1, 2, 3, 4, 5, number 6 here, and again that's where the heater attachment is for the type 58 tube, and again you can see it tied to the transformer itself. Now pin number 1, if you're looking at the schematic, again you got to have voltage for both. So again 1 and 6 is your heater voltage of 2.5 volts. And again you can see in this case they've got pin number 1 tied to the chassis ground. So that would be your other point of contact. And again we saw where we had this lead itself going to chassis ground. And if we follow this lead over here off of the type 58 tube, we should indeed find that it ties itself back over to the other tubes, the 57 and the 2A5, to be able to get the heater voltage for those as well. I'll confirm that, but that would... Okay, that is indeed the case here. Let me see if I can move this where you guys can see it. So we've got this one connection point again coming from this pin location, again, which is pin number 6. And it comes back over here and ties in again to the 57 tube, and then the 2A5, if I have them in order, right back here. So again, that's just your heater string voltage. Alright, let me go ahead and get this cut loose here. 2 more leads. So for those just getting started in the hobby, what are they? I didn't call those out just a bit ago. But you can see they're the primary to the transformer. Again, this particular radio is kind of unusual for that period. It calls the input voltage all the way up to 120 volts AC. And this symbol here is the switch itself for the on and off. And you can see, again, they attach themselves here to a terminal strip. One, of course, is your direct line input feed, and the other side here, again, should loop through the switch itself and tie back to this point. Let me just take the VOM between these 2 points here, and let's just check. I know the switch. Alright, let's flip it on. And here in just a bit we'll go ahead and read the primary DC resistance of the transformer as well. You'll typically read anywhere from 8 to maybe as high as 20 ohms or so. But I usually see 10 to 15 ohms of DC resistance on the primary side. So let me go ahead and get these cut loose as well. I don't have a whole lot to work with here on this one, so let me see if I can just desolder this. Wow, it was just laying across there. Let me go ahead and do the same for this one. And again, you can see it was just laying across the strip. Alright, I think that's all of our leads. Again, we got this one probably center tap location on the transformer that's not being used. It's just coiled up here. Let me go ahead and get the fasteners here removed. Grab a nut drive, and let's pull the old transformer out and take a closer look at it. It does make me wonder now if this was the original transformer. Maybe so for the period, but this fastener is a different size than this one, and you can see this one's bent as well and off to the side. And of course we already know this fastener is different as well. So let me just get the assorted nut drivers, and I won't bore you guys with this on video, but let me just loosen these 3 connection points up, because again the 4th one, the ear on the transformer, again has been pulled back here. One thing to be mindful of as well is the old windings here can be very, very fragile. So again, I'm not trying to put a lot of pressure down at the base of the transformer. And it looks like the way this transformer is made, there's just a grommet here on the back side or the bottom side of the transformer where all the leads go through. So I think I can pull these through now fairly successful. Let's see what happens here. It'd help if I get this one more fastener completely loose. I'll tell you, it's a tight fit down through there. And once I get this sucker out, I'll tell you what I'm going to do. I'm going to drill a bigger hole in there. Alright, I can't do this in front of the camera here. Let me just set this down and see if I can position these leads here to get these wires through without creating any substantial damage. Okay, looks like I escaped any damage there, fraying of the wires. I know there's a few other folks on the Antique Radio Forum that have done restores on these. Be curious to know if your transformer was Pepco Peerless Electrical Products out of Los Angeles. Let's validate the transformer and get the approximate voltage readings here that we can anticipate once this thing's back in circuit. You can see I've got a couple leads hooked up here. I already know these two leads are my primary input leads, and the reason why they have solder on them, and again I just untacked those from the terminal strip there where it fed the line cord back over to the on-off control. My input to this, as you can see in the picture-in-picture, is nothing more than my audio signal generator. And again, I'm generating a signal right at 1000 Hertz. And that particular AC waveform was set to around 5 volts. So let's see how close that is now, if that's changed much. That was just a bit ago. And you can see there on the meter it's fairly close. Now again, I've already done some DC resistance measurements, and there's nothing in common between these two filament or heater connection points and then these three at the top. So I've separated those just looking at DC resistance. So what that tells me, just looking at the schematic here, that the 5 volt winding here, this secondary that feeds the filaments here for the type 80 tube, or most likely this one and this one. So that leaves these three. Now again, doing DC resistance measurements, I know this is the ground connection because it was the longer lead that was soldered to the chassis ground. So we can hook up here, and I've already done this looking at DC resistance as well between ground and these individually. And of course there is a bit of difference, but again, you're looking at real impedance readings that are extremely low, so they're hard to really see. You're looking at 0.1, 0.2 ohms or so. So in this first lead that I attached to, you can see I'm reading 0.061. Now just a bit ago I did this exercise, and look at this line here. I read 0.064 volts. So you can just call it 0.06. I'm going to divide that by my 5 volt input, and that comes out to be 0.0128 volts. I can actually multiply that by what I think my modern day voltage will be, 120 volts, and you can see theoretically this transformer would provide 1.5 volts AC between this ground connection here and this connection point. Now if I move over to this location, And you can see on the meter itself I'm reading 0.125 just a bit ago. I did the same exercise. I read 0.128. Again, dividing that by 5 comes out to 0.0256 volts. Again, multiplying that by 120, you can see that gives me around 3. So I think this is the tap that was actually used in the radio itself, not this one, because again, if you look at the heater voltage requirements for the tube, 2.5 volts, and again, this is without load. Now let's move down here to what I think is the type 80 filament inputs. We'll let that settle down, and again you can see 0.246, and that's a perfect match to what I had here. Again, doing the math comes out to right at 6 volts, and again that tube spec for 5. So again, the line voltage back in the day in the 30s, of course, was typically not in the 120 range. It was in the 110, range, sometimes even less, 105. But I think we'll be just fine once we load this down. Now we can do the same for the secondary of the high voltage as well. Again, we already know this is the center tap location. Let me show that on the schematic for folks that are new. It's this location right here is what I'm looking at. Center tap of the transformer on the secondary side, and you can see that it attaches itself up here to the field coil, and that's what we saw when we desoldered that. So again, I'm going to test from the center tap over here and just pick one of these locations at random, and you can see I'm reading just a little north of 14 volts. If I go back to my documentation here just a bit ago, you can see I read 14.31. Again, if I divide that by 5, it comes out to 2.86 volts. Again, multiply that by my anticipated modern day line voltage. You can see again from center tap back to this side, I would anticipate seeing somewhere around 343 volts. If I move this one over to the other side, 14.37. So I think it was this one. Again, 346, 347 volts is what I would anticipate seeing. So again, across the entire string, looking at the voltage here between points P3 and P2, again, which will be the plates for the type 80, I would anticipate seeing, if I brought this up on the variac, somewhere around 691 volts in total, as you can see here in the math. So I think this is another helpful plus a safer approach to testing the high voltage transformers. I'll use a variac as well at times to bring them up so I can understand the AC current, etc. Now again, I'll go ahead and continue doing my DC documentations, resistance measurements here, and I'll document those on the schematics, and I'll cover that in just a bit. Also, one of my great subscribers and someone that follows along, I remember one time I was testing a transformer, I think more than on one occasion, and I failed to test between all the conductors and the frame of the transformer. So if you're out there testing transformers, be sure when you're doing your DC measurements, etc., that you make certain that you have no resistance there between any of your leads and the bell housing, again, unless it's tied to a known ground location. Real quick before we move along to something else here on the chassis, again, everything's documented here, so for folks out there that need this for reference, I hope you find it helpful. Again, just under 14 ohms here on the primary DC resistance. This particular transformer, again, and I may have these may be swapped because I can't really tell now, but again, 0.396 K and 0.422 K And again, that would tie into my calculated voltage readings as well. And then for the 5 volt winding here for the filament of the type 80, 0.35 ohms. And you can see the math does work out here for the tap off here for the heaters for the remaining tubes. The 3 volt winding read just a bit more, 0.2 ohms, versus the 1.5 winding reading 0.05 ohms.